Good afternoon, ladies and gentlemen. About a few honors. Good to see everybody here today. We stopped yesterday after working on problem 12, and what we had, the last thing we looked at was B, which is finding the average rate of change. And to find the average rate of change of the first 1/2 second, we plugged in 0.5 seconds and got an output of 284. So we have 284 minus 200 over 0.5, which is 168 feet per second. And the last half second, I'll show you where I did this in the calculator. The last half second, we had 684 minus, we plugged in 5 for X and got 680. So here we have 684 divided by 680 over 0.5. And so here we see the change in the average rate of change from the earlier part of the flight to the later part of the flight. And then it says, finally, check your answer by graphing the model using a graphing calculator. So what I did is I placed these two functions into the graphing calculator. Now, do you notice that I put both versions there? Yeah. Okay. And also I changed the window to match the flight of the fireworks. And when I press graph, what should I expect to see?
The same thing.
I'll see the same thing, but I engineered it that we're going to see which graph first. The blue one, which will then be covered up by the red one. So we graph, and it goes pretty fast, so I'm going to press right now, 3, 2, 1. That was really too fast.
I saw it.
You saw it? I must have blinked my eyes.
I think it's because it's already there.
already
You
there.
have to
Yeah.
redraft. You have to read. So like,
So clear it all and
You don't need to, right? You just delete the zero, like at the end of the 200 and then put a zero back there on
or
it.
just do it.
I'm just going to try it this way, see if that works that
There
way.
you go.
We'll see if that works.
Did you make a salsa?
Yeah, there it is. There, I saw it that time.
dope.
That was so much fun.
That was fun, yeah.
I mean, it was
Now-
kind of like an animation, like a
Yeah, it is.
Disney Pixar.
Now, the thing you can do that, even if you don't have a CE calculator with the color, you can still do it. But what you have to do is you have to change the line thickness. Do you know what I'm talking about?
Yes.
You know, Emma knows what I'm talking about. So we could do that at some point. And then you can look at the table view and other stuff. Let's go ahead and look at problem number 13. Okay, and what I'm going to do is I'm going to pick randomly people, but I want to show you the first thing. And we had what is the standard form equation? It's going to be h of t
equals negative 16t
squared.
squared plus 176.
Well, no, that's not what it's supposed to be. The V with the sub-zero thingy.
Yeah, v sub 0,
Over 24.
but in this case v sub 0 is equal to 24 feet, so it's going to be 24t, and then h sub 0 is equal to 32, so we'll have plus 32. So here's our standard form equation, and we're asked how long does it take to reach the maximum height, and what is the height? Well, this is standard form. Could we graph this very easily and find what that is in the calculator? We could. Without a calculator, what would be probably the best way to do this?
Complete square.
Complete square. Emma said that, the comedian, Emma's a comedian. She said give up first. Thank you, Emma. But anyway, we'll have h of t, and we're going to take the negative 16 out front. And so we have t squared here. Okay, how do we get the next thing to put here? And we're gonna have plus something, or could be minus something. What do we multiply by negative 16 to get 24?
1.5.
It'd be 1.5, right? How'd you get that, Emma?
The calculator.
So if you take 24 divided by negative 16, that's going to simplify to negative 3 over 2, which equals negative 1.5. So I'm going to put negative 3 over 2 x, or t. When I said x, I'm going to put t. And how do we find out what number to place here?
Or don't you square out?
Divide by 2 and square.
You see, I said divide.
So divide by 2 and squared. So let's go ahead and divide this. If we take negative 3 over 2 and divide that by 2, what is that going to be?
0.75 or 3.
0.75, right? Or negative 3/4. And if we square negative 3/4,
It's 0.5625.
we're going to get 9/16. Yeah, it's going to be 0.5625, right? But we're going to add 9/16 here. And what do we have to add out here?
9/16.
9/16 plus 16.
Okay, we have to, it'll be negative 16 times 9/16, so that's going to be negative 9, right?
Yeah.
But we have to add out here, right? So now we have h of t is equal to negative 16, and we're going to have t minus what? T minus,
3 over 2.
well, what we have to do is we have this 3 over 2, but we have to divide that by 2. So what's 3 over 2 divided by 2? 3/4. We square that, and what goes outside here?
The plus 9.
9 plus 32? 41. So now, can we answer the question, how long does it take the pin to reach its maximum height? It takes how long? 3/4 of a second, right?
So you should take me off of the wheel since I answered that.
No, you're gonna want to be on the wheel. You're gonna want to be on the wheel anyway, because that's the way you are. Okay. And then, what is its maximum height? Maximum height is equal to 41 feet. Here's what I'll do, Emma. I'm going to leave you on the wheel, but if you don't want to answer it, we can skip you, okay?
She can pick somebody.
Okay.
So I'll give you an option for that.
Don't say that. She'll pick me.
Okay.
Okay,
I don't know what to do.
so now the juggler misses the pin on the way down. On its way down, how long after the pin does it pass the juggler on the way down? How long is it going to be?
Should you gonna help me?
Wouldn't it be the vertex?
So here's our vertex, right up here, which we know is the point 3/4, comma 41, right? That is our vertex. And so we have our juggler starting out here at 32 feet. So how long is it going to take? We throws the pin. How long is it going to pass?
1.5 seconds.
So 1.5 seconds. So 1.5 seconds, she says. How do you know that?
No clue.
Because I multiplied 3/4 times 2.
Okay, 3/4 times 2 is equal to 1.5. That's how she knows, right? Symmetry. Here's your axis of symmetry. Here's 0.75 seconds. 0.75 times 2. That's it. Okay, so we have all this right here.
You gonna help me on this? I don't know what to do.
So say it would be the same type of thing. Now, is it, I'm trying to think, remember number 14. Anyway, any questions on this one? So I want you to work on number 14. It's going to be the same type of process, except what? You got negative 4.9, all right? And you remember me talking about negative 4.9 yesterday a little bit?
Yeah.
You did, right? Now, Christian didn't.
Yeah, Mr. Jim.
So just work on this for a couple minutes. I'm going to pick somebody's name
Can I do that real quick?
randomly, yes. But I might pick your name, right? Are you ready when I pick you?
Um,
Go ahead, hurry.
yes. But if that's my name, I'll know what to do. I'll try my best.
She's gonna be sprinting.
Oh, I forgot my mask.
You look cute.
Thank you.
Me too.
Chris, you're wearing basketball shorts. No,
I fuck with every day, bro.
it's picture day.
You want to eat next?
Show up.
I was tired of it. I was mad at me. Mr. G, you gonna help me whenever if my name gets fixed?
Well, I might, or maybe Emma will, or maybe
Maybe the
Luke
whole class will.
will, or maybe Steve-O will help you. Steve-O was very helpful. You know that, right?
I love Steve. I'm a boy. Right, Steve?
I might not be helpful.
You're on your own here, Chris.
Victoria can be helpful too. Victoria, you know a lot.
No, you're on your own.
It's because Mark.
What about you, Jace? You see what's going on here?
Yeah, I think I could help him.
Okay.
I can too.
I cannot.
Jason loves me for it.
Marcus kept the calculator, so I don't even
What
have
was that?
Oh, really?
that. Yeah.
All right. You want to borrow a calculator, Steve-O? I got one.
I don't mind.
Yeah, I'll lend you a calculator here.
We gotta go. Understand?
If I get a calculator, I could help.
You better say mom.
Now, to me, the negative 4.9 is harder. What makes negative 4.9 harder to work with than negative 16?
It has decimals.
Yeah, it's more decimally complicated, I guess you could say that. And so the numbers don't round off as neatly. And so my recommendation is you can take it out to 3 decimal places and you'll be good. So yeah, you expect to be working with decimals on this one. Okay. So now, yeah, that's just a recommendation. And I think the book had it a little different here. I'll open. Let's go to 7th period. We have everybody here, even Elijah.
Let me go quick. Yeah.
Okay, we got
9:30?
I swear.
Emma. So Emma here, do you want to work this one out? Or do you want to have someone else work it out?
No, I don't want to do this one, that's what you guys. Don't remove me.
You don't want me to remove you?
No.
Yeah, I chose, you remove him, here. There's your choice, here. I gave you choice.
Okay, it's fine, it's good.
It'll be Christian, all right, Christian, you'll be good, Christian, you'll be good.
You'll do great, Bruce.
Yeah, he will.
I mean, I get me out of the way as soon as I heard.
Okay, well, yeah, what we'll do is get you, yeah, what we'll do is what is the first part of this?
Right, it's very
That's what I did. That's all I did.
That's all you did?
Isn't it, didn't you just copy down the equation that's been given?
Yeah, you can just copy down the equation, let's do that. So we have negative 4.9
Right?
t squared,
Absolutely.
and what's the next thing here? Plus,
Sir?
what's the next thing here?
Plus.
Plus,
30.
30t, right? Plus, plus 2. Okay, so that'll be our first step, the writing and rendering in standard form, right? So next step is we're going to try to get our vertex form. So how do we get our vertex form?
But 1.9 outside of the
So negative 4.9, open parentheses, and then what goes here? T squared. Okay,
It's not like a basketball court.
and what's the next thing to go here? By the way, I'm going to put plus something over here.
Would it be minus 6.122?
So she got minus 6.122
0.12.
t. Is that right? How did you get that?
By 2 and square root. Well, you have to divide 30 by negative 4.9.
So let's take 30 divided by negative 4.9. What do we get for that? That's going to be 6. Or what is that going to be?
It's like 6.1228. I really did it. I figured it out.
So negative 6.122. And what's the next thing we need to do? What do we have to do with that negative?
We'll divide that by 2.
By
and
2.
square it.
So we divide by 2, we get negative 3.061, right? And then if we take negative 3.061 squared, what do we get with that? We'll get 9 point something. What do we get? 9 point,
369.
so we'll call it 9.37. So we're putting 9.37 out here, right?
Do you not do it to 9.371? But then you said.
Yeah, you could do that, and I'll do that. You could do that, so I'll do that. I think it becomes less important, but 9.371 we call it. Okay, we can call it, right. And so, and out here, what are we going to do out here? We're going to have to add, we know we're going to have to add the 2, right? But what are we going to have to add to compensate for this thing right here?
Like 3.061?
No.
Is it gonna be times negative 1.9?
Yeah, times 4.9, so 9.371 times 4.9 is 40 something.
It's 45.917.
45.91. We'll call it 45.91. And so now we have, can we write this and can we complete this here? So we have T, it's going to be T what?
How do we know what to round to when you round to different things each time? Because like sometimes you're on to 3, sometimes you're on to 2.
Okay, I have a question about rounding. I know that's something, I do want to show you something a little bit, Victoria. Let's park that off to the side for a little bit. So what number goes in here, though? 3.061. And what goes outside here?
You know what your atlas things?
47.91. And so can we answer the question now? How long does it take? It takes how long? Seconds. It says at what height to reach height of what's our height reached? 47.91 feet. Okay, Victoria was asking about decimal places. And I like you guys in decimal places to, when you can, to go out to at least 3 decimal places. And there are a lot of reasons for it. In this case, I'm going to show you. I'm going to show you the books. I'm going to show you what the book. Who said that? Very good. Yes, it is meters. Good catch. I was just too used to writing. I was thinking of Victoria's question. Okay, what happens in calculus? We get to calculus. The calculus AP standard is to round to 3 decimal places. So that's just a standard. For practical use, if I said 48 meters, would that be probably close enough to explain to somebody? Yeah, right? And so the idea of when to use what decimal places for rounding, that's one thing that is an ambiguous thing. One thing you have to remember is that when you're using an answer for a preliminary answer, like in this case, when you think about it, this 6.122, that's a preliminary answer, isn't it? Because what do we have to do with that? We have to take half of that to get this, and then we have to square this. And so what that means is that inaccuracies are going to compound the less you take it out. And so that's why the 3 decimal places at this level is usually going to be good enough. But again, that's a matter of opinion. I'm going to show you the book here.
So why did you round to 3 on the 47.91?
Why didn't I? I didn't. That's the only one I had. That's the only one somebody gave me. Nobody gave me anything else. So I put down what I was told. Let me show you something here. See, these are the answers the book gives. 3.06, 47.9. So we went a little more accurately than they did. But that's what's in the textbook, okay? And usually, the way I work it out, I'll usually be another decimal place more accurate than the test number booklet. But does that mean the text is wrong? No. Victoria, you sort of have a, because I know this has been not the first time you brought this up, so you have an attention to detail that I would say is commendable. All right, now 15. Explain the error. I'm going to choose somebody for this one. Oh, by the way, I want to, you did work with me a little bit. I know people helped you, but I would still give credit. Yes?
I don't mind actually.
No, I'm going to choose somebody. And yeah, I know this is probably a pretty easy one, but still we're going to use the same thing. We might pick your name anyway, Steve-O. It'll be Victoria again.
Can I get that?
Okay, Victoria, can you help us out with 15? So what was your question?
For the third one, how they didn't do it, like, if they have minus 4x plus 4 and it shouldn't be 4, because they didn't like divide by 2 or square or anything.
But you divided by 2 and squared.
So here we have step 1 and step 2, they look the
What do
same.
you divide by 4?
But step 3, what do you notice?
Because do they not divide 4 by 2 and square?
So which one is incorrect, do they say?
Never mind. I don't know.
The A is
A.
incorrect.
A is incorrect, okay? A is incorrect. And it says, explain the error. And I think you explained, right? Because what did they forget to do? They forgot to multiply by 2, right? So in A, they forgot to multiply by 2. Was that the way you said it? Okay. Because he forgot to multiply this -4 by 2 to get -8. Okay? Does that work out pretty well? Now what I want you to do for number 16 is not do 16. We're going to just go on to 17. So once
Maybe you make a salsa.
I don't know, it's not going to be for tomorrow.
Why didn't I get a little skinny thing?
Got it? Do you want?
No, I'm kidding. Anyhow, I'm talking about, you said it.
Oh, like this?
Yeah.
I don't know. I was just being silly.
I'm just kidding, Mr. G.
Jealous.
I'm jealous, Mr. G.
Just being a little
I'm
silly.
gonna cry. Go home, start calling
Have a little
myself.
fun. Okay.
That's why if you start crying and start laughing.
All right.
Yeah, I kind of cry over this, dude.
So I'm going to pick somebody for this one here. We'll give them two different forms here. So somebody new is going to be picked.
It's gonna be Luke. Steven.
Steve-O, you got picked here for number 17.
How about Finn?
All right, Steve-O. What did you, are these the same?
They're solving it.
Okay, he's working on it.
Yes,
Okay, Steve-O says they are the same. How did you work it out, Steve-O?
First you have the 2, which will make it a 1, and then you need to square it, which will be a 1.
So did you square this?
No, the other one.
So you worked this out here.
Yes. And so we x squared plus 2x plus 1, and outside the parentheses it's minus 1 minus 2, which will make it minus 3. And to make it, to take away the square in the outside, it'll make the 1x, so it'll be x.
So you divide this 2 by 2, right? And get 1. 1 squared is 1. And so you have to subtract 1 out here is what you're saying, right?
Yes. After that, you'll need to square out, and it'll be x plus 1 squared minus 3. That is the exact same thing as the one above.
So what Steve-O did is he took that first one and completed the square on that and got this. Now, the way I did it was the opposite way. I took this one first and took this, if you take this x plus 1 squared and subtract 3, if you square this out, and it's really a matter of preference because either way works. So you have like x plus 1, you get x squared plus x plus 1. So you get x squared plus 2x plus 1. And then if you subtract 3 from that, you get x squared plus 2x minus 2. Okay? So it really doesn't matter which way you do it if you understand what you're doing, okay? And next, we get to 18. And here's 18 over a given time interval, and I'm going to call on somebody for that. I want you to think about 18. I'm going to call on somebody else. One thing I found on 18, making a sketch of what's going on can be quite helpful to you.
Oh, I think I got this.
Okay, Bailey thinks she has it. Bailey is getting on the short list now. So really it's going to be a 1 in 3 chance effectively. But we're going to get Jace on this one.
I knew this one.
Okay, Jace, what do you think?
I think that over a given time interval, a golf ball, it has a rate of change sometimes, it does. And it's 0 sometimes.
Okay, but you asked the question, does this mean the ball is moving horizontally?
Horizontally. I think it does mean that.
You do?
Because if there's a rate of change of height of 0, that means it's staying the same height, which means it has to be horizontally going. Technically, there's not a change.
Okay, guys, it says the golf ball in flight. So what I'm going to do is I'm going to try to allay misunderstanding of the situation. So the golf ball is struck, right? And you got a golf ball flight. And a golf ball flight is going something like this. And so let's say between 0 and 6 seconds, between 0 and 6 seconds, what is the average rate of change?
It just said 0.
It is 0, right? Because started on the ground, finished on the ground, average rate of change is 0. Does that mean the ball was moving horizontally? Is this ball moving horizontally?
But if its height change is a rate of 0, that means it doesn't get off the ground.
That's exactly what it's telling you.
Then
It
that
says
means-
flight.
That means
Then it doesn't move.
Okay, average rate of change. Do you understand what average rate of change is?
Yes.
Average rate of change
It's slope or velocity.
is equal to the final y value minus the starting y value minus over b minus a. Here we have b is equal to 6. Here we have a is equal to 0. So in this case we have f of b, which is 0, minus f of a, which is 0, over b minus a, which is 6 minus 0. So 0 divided by 6 is
7.
0.
So it
Then they
doesn't
need to
have,
reword the question, because if it says the change of height is 0, then technically that means it doesn't get off the ground.
No, it says average
it
rate of
doesn't think about
change.
this place, oh wait.
It's average rate of change. Now,
In my mind, logical.
now if we go ahead and say, okay, 3 seconds,
Does this have to do with like displacement and stuff?
yeah, it does. At 3 seconds, we have a height of 50 feet, right? Now, if we're going to find average rate of change for this interval of time, so it depends on the interval of time you look at. But between time equals 0 seconds and time equals 6 seconds, the ball was up in the air, but when we took the snapshot at t equals 0, the ball was on the ground. When we next took the snapshot at t equals 6, the ball was on the ground. So the average height between those values, 0 and 0, is
0.
0. Now, in the case of this one right here, if we took 3 seconds, let's say for 3 seconds, we would have f of b minus f of a over b minus a. Here we would have 50 over 3. That would be our average rate of change if we look at these two times, 0 and 3. We look at 0 and 6, in this case, our average rate of change is 0, because that is the average between that elevation of 0 and that elevation of 0. Yet, does the average rate of change explain what happened between time equals 0 and time equals 6? No, it doesn't. What is the only thing that really explained anything about it? A flight, right? So that's what an average rate of change is. So no, and I explained what it is. Okay? So lastly, we go to the world of volleyball in problem 19, our lesson performance task. And here we have used this function where v sub 0 is the initial velocity and h sub 0 is the initial height to write a function h in standard form. And that function in standard form is going to be h of t is equal to negative 16 t squared. And what goes next in standard form? 20, right? Plus 4. Now, is that what would happen in an actual volleyball game? Yeah, right? Jace, you do those bump ups with the volleyball like this?
Yep.
Is that from a height of about 4 feet maybe?
Yeah.
Yeah. So realistic. By the way, you guys, when are you guys playing? You're playing tomorrow?
Yeah.
What time are you playing?
My team plays like last.
Oh, you'll be last, okay, so 6:30 or whatever. All right, very good. So now, So now we have that, so how do we complete the square to rewrite h in vertex form? Well, we have h of t is equal to negative 16 t squared. What's going to go next? Yeah, 20, but remember we've taken the 16 out of here. So what's it going to be? 20 divided by 16, which is 20 divided by 16, is that 5/4?
Would it be negative?
Yeah, wouldn't it be good?
Would be negative. I think it would be negative 5/4, right?
Yes, sir.
T, and then plus something we haven't figured out, and then add 4 at the end. So how do we figure what this is?
Divided by 2.
Divide by 2, square it, so we get, that'll be 5/8. So negative 5/8, we're going to get 25/64, right? And over here, we're going to add 25 over 4. And so that's going to be 10.25. So we're going to get h of t equals negative 16 t minus, we have this, what is that, 5/8 squared plus 10.25. And I know I sped up there at the end, and we didn't actually do part D. We were sort of running out short on time, so I had to just hang on to that.